Since my computer is shut down, let's quickly uh, let me quickly follow up post processor post process we just did. Scale display folder SST on the line. That's sorry, reporters. What? 2.5. 0.5, create 4.5 meters, 4.5, 4.5, create, close. Okay, let's look. I'm going to change as a simple, right? Control, before definition. Not this one. Monitor, schedule, uncheck, uncheck, uncheck. Okay, resolution, initialize, initialize, calculate, 1000. Okay, it looks like it is converged, right? Right, ASIN data here. Okay, here the XY plane, XY plot, not this one, profile, not this. Yep, this one. Yep. And to file here, profile. Okay, same date. Okay, let's open our okay, here is the what we obtained from the ANSYS Fluent. Okay, let's continue. So here, this one, it is difficult to extract. So I'm going to open the Excel. So here, if you see 찾아보기 over here, and then let's see. Not this one, modern file, and click this guy. Here it is, you can click all of them, this, then click the matching. In the case you can get those value like this, okay? It's quite easy to understand. So let's create another one. Okay, let's copy and paste this guy. Here, this will be, as you can see over here, this is x equal 1 meter, right? Be x equal 2.5 meter, 0 meter, 0.5 meter. This one will be x equal 4.5 meter. Okay, this is what we obtained. So obviously this one will be velocity, meter per second, and this is the y value, meter, same as here. This is what we obtained. So if we, so here we will plot this guy, right? So as I already mentioned, let me see. This is our table. And so here's at. So if you go back to our this is see, sorry, there's technical difficulty. This is your homework. Create the comparison. The x-axis is the u velocity divided by upstream velocity. So I'm going to put this guy over here, and let's make u the velocity x-axis first, y-axis. Y-axis will be y squat upstream velocity vx. Okay, not v. This is new. Okay, so this one will be simple. This small u should be this guy, right? Divided by the large u, our case is 1 meter per second, right? So this one will be this guy. Okay, so you can see it is automatically we can get the good value over here. This one, second one, the y will be this guy, and the squat of velocity will be 1 divided by nu. We don't know nu, so here let's make a nu viscosity. So this one, let's show you viscosity. So here, the kinematic viscosity its definition is basically your nu equal the viscosity divided by the density, right? So this value we needed. So let's go back to our ANSYS Fluent. So here, the nu will be nu divided by density. Density is the law. Okay, so here view rho. So this data we can extract from the material tab over fluid and air. The density will be 1.225. So this is the SI unit. Just I'm going to just copy and paste 1.225. It's 1.225. And this one is the viscosity 1.7894 10 to the minus 5 here. Okay. So this is the good. Okay. And our value nu will be nu divided by rho. You can see. So this is our nu value, the viscosity, kinematic viscosity. Okay. So let's go back to this one again. So y will be y times squat is the root. The squat means the root is the upstream velocity will be 1 divided by make the another bracket over here. In the bracket will be nu. Nu will be this one. I'm going to put the absolute the coordinate system, and then x. X will be here. This is 1. This is 1. Okay. This is our y-axis. This is will be eta. Let's see, this is properly extracted. So this will be copy and paste, copy and paste. That's it. But the thing is here, the x value also change, right? So I'm going to change this x value here as a 2.5. 2.5, then change it. So here as a also change as a 2.5 because this is the velocity profile from the x equal 2.5 meter, right? And this one will be 4.5. 4.5. Okay. So let's compare all the result. So first, I'm going to compare this guy first. So I'm making another sheet. This one, this one, this one, and this one. Okay, so this is our original profile. So let's see if this is correct. But so here, click the insert button. Sorry for the Korean. And then this is our, I don't like it. This is our velocity profile. If we put title, this will be velocity meter per second. And here will be y value, right? Okay. And the second one is easy, just Control C and Control V. There is another orange line is coming up. So I'm going to change this, just changing this one like this. Okay. This is the second one. This is the first one. Okay. And then Control C and Control V, you can create another one. this one, and this one. Okay, you can see there is the stuff. Okay, we can create this three line. So this gray one will be this one. This one will be this guy. This one will be this guy. Okay, so this is our velocity profile. So this is our data from the ANSYS Fluent. So this will be identical. So this data will be identical, which is obtained from the here, right? So the x equal 1 will be bottom. The here is the 4.5. Okay. Sorry, I made a mistake. Change. This will be correct. Yep, sorry. Anyway, this is our velocity profile from ANSYS Fluent. Velocity profile, ANSYS Fluent. Another one, let's copy and paste this guy on here. So if you just copy and paste over here, there is a, it will be the reason why if you copy and paste over here, the equation will be wrong. So I'm going to just copy and paste with the just value. Okay, 값 붙여넣기 over here, value. In that case, you don't need to worry about it is destroyed. Okay, so why this Blasius equation is so powerful? Let's see. So I'm going to create this guy. Okay, so let's do the same thing. Click this guy. Okay. Then copy and paste. Changing this guy to the right here. Copy and paste. This one. Change this guy here. Okay. But as you can see, there is a three line, so it's difficult to see. Okay. This gray one is coming from the x equal 1 meter. Copy and paste. Yep, very convenient. This one coming from this one from here, right? And this orange one coming from here and here. This one coming from here. Okay. And here the x will be eta, right? This one will be u divided by u. Okay. So as you can see, the order line is identical. but the previous one is the different, right? As along the x and y axis. But this equation is, as you can see, all the value will be matched in the one line. So let's compare this value with the table. So if I choose this table, okay, let's make another one. Table. Here f prime. Okay, let's go back to our PP slide. So f prime over here, this will be u over u, right? So I'm going to copy and paste this column. Second one. And eta as well. Eta. And paste. That is and paste. Oh, so to change this one as taper. This one. This one. I'm going to delete this one. Okay. This one will be table. So let's expect. Here, so many lines, so I'm going to delete it. So here, 4.5 will be identical. I'm going to delete it. And 2.5, this orange one also, so 2. Okay, so here, let's compare our result over here. So as you can see, so velocity profile from our theoretical tables, so theory. So theoretical, the estimate the velocity profile, and this 3-1 is coming from the ANSYS Fluent, right? So as you can see, no matter what, we obtain our velocity profile in the ANSYS Fluent. So which means that, so if you go back to the display, color change. So this, I'm going to change as pink. Display. Okay. Okay. So even though we obtain the value from this one, this one, this one, okay? But if we use this table value, the Blasius theoretical value, in that case, uh, we can theoretically, analytically obtain all the velocity profile very quickly. I mean, even though we do not extract the data from the x equal 0.5, but by using this theory, we can also predicted the velocity profile. So what does it mean? So this will be, you don't need to calculate every time. So we can just using this table value and they compare the result. So if you see in the below, the eta will be the 5. In the case, this is almost identical, right? This is really great result, right? So uh, let's move on to the next level. So what if, so let's say this one first. What if I would like to uh, want to get the data at the 3.0 meter, okay? So from the theory, from the theory, the, the theory Blasius similarity. So this will be more easy. Okay. So here, the eta. From the eta, you can extract the x value. So what does it mean is that this means that here eta is this guy. So if you want to extract a y value from the, if you want to extract this guy, in the case y equal eta divided by root u mu x, right? So here we would like to want to know x equal 3 meter, right? So eta, this one will be 1, right? So 1 divided by mu 3. Okay, so let's make this one in the Excel sheet. First, this is the y value, right? Y value will be, I forgot, eta. Here is the theory, right? Eta. And then divide by squat u, large U will be 1 divided by this U will be here, U times X will be 3. Okay, here this is 3. Hmm? More or less. Why don't you just copy this one in here? Okay. Instead of using this one, just using this one like this. Okay. Then this will be our y value, right? How about the velocity? So velocity, we can extract it from this guy. The velocity will be this one times. So our original, the upstream velocity is 1, so just 1. then copy it. Okay, so this is x equals 3 meter from the theory and the Blasius similarity. Okay, so there is another tab, estimation versus Fluent data. Okay, and then let's go back to our ANSYS Fluent. And let's create another line in the result tab, create line x equals 3 meter. So this one, 3 and 3, 0.07, create it. And then here, xy plot, not this one, and then extract this one, right, file, and this will be velocity profile at 3 meter. Okay, and then let's go back to the here, open with the notepad. In the case, you can get those values. Okay, let's copy it over here. This will be from the Fluent. Okay, let's compare those two values. This one, copy. Okay. So this one will be y meter. This one will be velocity. Okay. Celsius. Similar AT process font data. Okay, so as you can see, even though before we extract from the Fluent, we can theoretically uh, estimate the x equals 3 meter very fast by using the theory. But as you can see, the compared to the Fluent data is almost identical, right? So which means that our data, our result is quite I mean that this similarity equation is very powerful because even though without using any differential equation and without using any the CFD program, but we can successfully obtain this velocity profile just using this table, right? So, which means that this one is very, very powerful. So this is what I want to tell to you guys. Okay, so here this is your homework. So okay, so unfortunately most of part I already show the result. So I'm going to a little bit change our homework. So I'm going to change this one will be x equal 1.5 and this one will be oops. Oh my God. Anyway, 1.5, this will be 3.5, and this one will be 4.0. Okay, so this will be your homework. Okay, then I'm going to upload this one in your on your the lecture note on the e-class. Okay, so again, so let's briefly review our agenda again. So no. Yeah, here. So to obtain this velocity profile, you can use Navier-Stokes equation, you can use Euler's equation, or you can use the boundary layer approximation equation. Okay? So to use the Navier-Stokes equation, Euler's equation, you need to solve those kind of the equation, right? But as you know, to obtain the good data by using this solving the differential form equation, it is quite difficult. So in that case, we always need to rely on the CFD program. But if you use the Blasius solution, the Blasius similarity, in that case, just using this table value, okay, and then we obtain those graphs, then just extract, if you want to obtain the x equals 3 meter profile or 0.5 meter profile, you can just using this table value and then you can automatically, you can get the result within 1 second. So this one, without solving differential form equation, just using this table and solving the simple form of this equation, solving this simple equation, in that case, we can obtain very good results compared with the theoretical approximation. Compared to the ANSYS Fluent result. So I would like to highlight today's lecture. So if you have any question, so feel free to send any email to me. Okay, thank you. So this is the end of the today's lecture. Okay, bye bye.